guys, today let's discuss about the addressing modes of 8051. Okay, first of all, what is an addressing mode? An addressing mode is a way to locate a target data, which is also called as operand. In order to locate the operand, we use addressing modes. The 8051 family of microcontrollers has 5 types of addressing modes. Okay, majorly we can see 5 types, that is immediate, register, direct, register indirect, and indexed addressing. Okay, let's discuss about each and every one. First of all, immediate addressing. What is immediate addressing? And in immediate addressing mode, the operand which shows the opcode is a constant data of either 8 or 16 bits. The name immediate addressing came from the fact that the constant data can be stored in the memory immediately follows the opcode. That is very important. Okay. The constant value to be stored is specified in the instruction itself rather than taken from the register. Okay. In the instruction itself, we can see the immediate addressing, that is we can see the constant value in the instruction itself. The destination register to which the constant data must be copied should be the same size as the operand mentioned in the instruction. Also, the immediate addressing is very fast as the data to be loaded is given in the instruction itself. Okay, let's look at an example. That is MOV A hash 030H. Here accumulator, A stands for accumulator. The accumulator is loaded with 30 hexadecimal. Okay, the accumulator is loaded with 30. Yes, let's discuss about register addressing. In register addressing mode, one of the 8 registers R0 to R7 is specified as operand in the instruction. Okay, any one of this register R0, R1, R3, etc. will be present in the instruction. If it is important to select the appropriate bank with the help of PSW register, let us see an example. Okay, let us here you can see the example is what MOV A, R5. That is, here the 8-bit content of the register R5 of bank 0 is moved to the accumulator. This R5 is in the bank 0 and this will be moving to the accumulator. Not this, its data. The data which is contained in the R5 register will be moved to the accumulator. Okay, that's it. Then direct addressing. In direct addressing mode, the address of the data is specified as operand in the instruction. Okay, the address, the data's address, the data which is to be used should be having an address, and that address will be specified in the operand in the instruction. Using direct addressing mode, we can access any register or on-chip variable. Okay, this includes general purpose, that is RAM, SFRs, etc. Okay, example is MOV A, 47H. Here the data in the RAM location 47H is moved to the accumulator. That is, this 47H is the location of the RAM. This is the location of the 47H, and the data which is present in this particular location of RAM will be moved to the A, the accumulator. If the data was 1, this will be going to the accumulator. This 1 will go to accumulator and the content of the accumulator will become 1. If it is 10 and this accumulator will be 10, this will be moved from RAM location to the accumulator. Okay, let's discuss about register indirect addressing. As the name suggests, in the indirect addressing mode or register indirect addressing mode, The address of the operand is specified as the content of a register. Only R0 and R1 are allowed in indirect addressing mode. These register in the indirect addressing mode are called as pointer register. Okay, let's discuss about an example. Okay, move a comma at R1. The at symbol indicates that the addressing mode is indirect. Okay, this is the indication of addressing mode as indirect. Okay, if this symbol is seen, you can simply recognize that this is indirect addressing mode. Okay, if the contents of R1 is 56H, for example, we are considering this is R1, and it has the value 57H. So I'll take another color. Okay, 56H, as I mentioned in the example, this content is 56H. For example, then the operand is in the internal RAM location 56H. Okay, if the contents of RAM location 56H is 24H, then this 24H is moved into accumulator. Is it clear? If the contents of R1 is 56H, for example, the operand is in the internal RAM location 56H. If the contents of RAM location 56H is within this 56H, we have 24H. Okay, so this 24H is moved to the accumulator. Okay, that is what is happening in the indirect mode. Okay, then in text addressing mode. With in-text addressing mode, the effective address of the operand is the sum of the base register and an offset register. The base register can be either data pointer, that is DPTR, or program counter PC, while the offset register is an accumulator. Okay, the effective address of an operand is the sum of what? Base register as well as offset register. This is very, very important. Base register and the offset register togetherly forms the address of the operand, effective address of the operand. And in in-text addressing mode, only MOV C and JMP instructions can be used. In-text addressing mode is useful while retrieving data from lookup tables. Okay, MOV C A at A plus DPTR. It's very difficult to understand than the other types of modes. Okay, here the address for the operand is sum of the contents of DPTR plus the accumulator. Okay, we can see that the sum of this A and DPTR togetherly makes the address of the operand. Okay, let's have a look at what all things we have discussed so far. Okay, we have discussed about what all things? The addressing modes. First of all, what is an addressing mode, and the operand, all things we have discussed. Okay, and 5 types of addressing modes, and we have seen the examples for each. Okay,